Hey everybody, we're going to do solving quadratics by factoring. Once again, this is another Math 1 concept, but it was at the beginning of our Unit 5. So we're going to go through some basic notes just to refresh your memory on how to solve a quadratic by factoring. First of all, let's remember that a quadratic, so let me go ahead and pick up my pen color if you don't mind. Give me a second. Now I'm just going to use the word quad. A quadratic is a polynomial with a highest degree of 2. So in your example, 2x squared minus 3x plus 5 is a quadratic trinomial, means it has a degree of 2, and it has 3 pieces, so quadratic trinomial. We're used to seeing these in the form of ax squared plus bx plus c. Once again, it doesn't matter if you use capital A, capital B, capital C, but it's ax squared plus bx plus c. And you just give me a second. I'm going to go ahead and move our notes up a little bit. All right, so when we're talking about a quadratic and we graph a quadratic, this is the picture that you're used to seeing. Now, whenever you graph a quadratic, you know that it's going to give you a graph called a parabola. Parabolas can open up or they can open down. So you're probably thinking, what do we do with these quadratics? Well, the first thing we can do with these quadratics is we can graph those. We'll be doing that a little later on next week. The next thing we can do is we can solve for the zeros. We're going to talk more about that today. Sorry about my abbreviations, but we're doing the best we can with some video. Now, when we solve for your zeros, what are we doing? The methods that we're going to focus on today is going to be the factor and solve. You already know how to factor. Now remember, some of you factor using square box method and some of you factor using the double T, depending on which teacher you came from. Something else we can do for solving for zeros that we're going to focus on this week is going to be the quadratic formula. Okay. And last but not least, right now, another method for us is you can always use your graphing calculator. So today our focus is going to be on factoring and solving. Now, before we start factoring and solving, let's go over a couple things on your graph that we need to make sure we remember. Remember that we're going to be solving for these things right here called our zeros. These zeros actually have several other names. The zeros can actually be called the x-intercept. I will put that there. Sometimes you might even have your teacher call them roots. Basically, what does that mean? That just means this is where your graph is going to touch the x-axis at this point. Some other things we need to talk about when we focus on our graphs, not today, but a little later on, is that you always call the lowest or the highest point where your quadratic is going to make a turn the vertex. So down here, we've got the vertex point. Okay, my highlight's not doing fabulous, but we'll highlight in blue maybe. You've got that as your vertex. It could be your min or your max where it starts to turn. You also have something else that we like to call the line where it splits the graph in half. I know that's sort of hard to see. I wish I had some better highlight colors, but this point right here in the purple, that point in my purple, let me get out of this right now, is going to be called my axis of symmetry. I'll be having a video later on for us to talk a little bit more about that axis of symmetry. But today, let's focus on finding these zeros, finding the x-intercepts or finding the roots, figuring out where does my quadratic graph touch the x-axis. So I'm going to move our video down a little bit. Now, in the picture you just saw, our quadratic actually touched the x-axis 2 times. We will be looking later on that it may only touch your x-axis 1 time, and something else it may never touch. That's when we get into something called imaginary numbers or imaginary solutions. So we'll talk about that a little later on in the next couple of weeks. But today, we're going to focus on quadratic equations that tend to have 2 zeros, meaning it touches the x-axis twice. Now, in order for us to actually find our zeros, first thing we have to do is factor. So that's going to go right here. So factoring basically is the process of taking a quadratic trinomial and breaking it back down into the two parentheses or the two factors that if you multiplied would give you that quadratic trinomial. So that's the first thing we're going to have to do. So I'm going to go to our first example. And if you notice, I did tell you that we've got to use something called the zero product property to solve. Basically, we're going to set each one of our parentheses equal to 0. Why are we setting equal to 0? We're trying to find the x-intercept. The x-intercept acts as the 0 or the ground level whenever you're thinking about a quadratic graph. So the first thing we always have to do is make sure that we have been set equal to 0. If it is not set equal to 0, then that is our job. We have to have it equal 0. So look on number 4, and I apologize. You're like, where did number 3 go? I have no clue where number 3 went when I redid these notes for you. But we're going to focus on number 4 right now. And number 4 says x squared equals 6x. First thing I need to do, I need to move that 6x. When I move it to the left, it turns negative. Now, always look for GCF first. This is not a quadratic trinomial, means it does not have 3 pieces. So I'm either going to focus on looking for a GCF or seeing if it's a difference of squares. I do notice there is a GCF. That GCF is x, so I'm going to pull it out. When I take out an x from x squared, I'm left with x. When I take out an x from negative 6x, I'm left with minus 6. All that happens to equal 0. So at this point now, I'm going to take the x, set it equal to 0. This is my first part, my first parentheses, if you want to think about that. And then I'm going to take the second parentheses, the second part, my second factor, set it equal to 0. We're very lucky because the first one's already been solved for you. But the next one, we're going to add 6 to both sides. If I add 6 to both sides, I found out x is equal to 6. What does that mean? That means my quadratic graph would touch the x-axis at 0, and it would touch it at positive 6. It touches the x-axis twice. We're going to go to number 5. I'm going to focus on a different color. First thing I'm going to do is I'm going to notice that 21 needs to move. Okay, it's not allowed to stay there. Everything, whenever you solve a quadratic, has to equal 0. So when I move it, it's going to turn negative 21. Now, on this method, I think all of us just use a basic t-chart. So I'll write down the factors of 21, not too many factors. How can I get negative 4 in the middle? Now, I know there's no way that 1 and 21 can add up or subtract to give me negative 4, but I do think 3 and 7 would work if I make the 7 a negative. If I add these, they will make negative 4. So I'm going to put those in my parentheses. So I have x plus 3, and I have x minus 7. There are my two factors. Now I'm going to take each one, set it equal to 0, and solve. I'll move my paper up just a little bit. So x plus 3, set it equal to 0. Now solve it. That means x would be negative 3. That is one of my x-intercepts, my roots or my zeros. Take x minus 7, set it equal to 0, solve it. I'm going to add 7 to both sides. My other 0 is at positive 7. That means my graph is going to touch the x-axis 2 times at negative 3 and positive 7. We're on to number 6. On number 6, for this particular one, try and find a different color. First of all, I've got to have everything equal to 0. So when I move 36 over, it turns negative. Now, once again, this does not have 3 terms. So that either means that it's going to have a GCF or it's going to be a difference of squares. I'm looking, do not see a GCF between 25x squared and 36. But I do notice that 25 and 36, hey, they're perfect squares. So I can square root the front, square root the back. If you remember anything about difference of squares, that means one of my parentheses is going to have positive and one will have a negative. The square root of 25x squared is 5x. The square root of 36 is 6. So one of my parentheses will say minus 6. The other will say positive 6. Set it equal to 0. Now I'm ready to solve each one. Take 5x minus 6, set it equal to 0. Take 5x plus 6, set it equal to 0, and solve each equation. When I do this, I get 5x is equal to positive 6, and divide by 5, 6/5. Please leave things as fractions. That is the easiest form for everybody. On the second one, subtract 6, so 5x equals negative 6. Divide by 5, I get negative 6/5. Awesome. That means my graph is going to touch at 6/5 or 1.2, and it's also going to touch at negative 6/5 or negative 1.2 on the other side. We're ready to move on to our last 2 examples. Move it up a little bit more for us. There we go. Okay, same thing on these. Going to get a little harder. First thing I notice is that negative 6 needs to be moved. If I move it over, it's going to turn positive. So plus 6 equals 0. Now, I'm going to do square box method because I think a majority of you learned square box method. Some of you use double T's. Go ahead and do your double T. First thing I need to do on a square box method is I make that beautiful box, right? I put that 6x squared in the front. I put that 6 in the back. And now I'm ready to do 6 times 6, which makes 36. And I have to find the factors of 36 that multiply to give me 36, but add up to be 13. 1 and 36 will not work. 2 and 18 will not work. 3 and 12 will not work. Ooh, 4 and 9 sound really good. They do add up to be 13. So I'll go over here and put 4x in one box, and I put 9x in the next box. I'm going to erase a little bit so I can get my box going. So I'm going to erase that just to the side a little bit. All right, so now I'm ready to go back. So I go, if I'm doing square box method, I go sideways. What is the GCF between 6x squared and 4x? That is a 2x. What is the GCF sideways between 9x and 6? That is a positive 3. Now I do GCF of my columns. So 6x squared and 9x, that will be 3x. GCF between 4x and 6 is a 2. I'm ready to go ahead and put those in my factored form. And 3x plus 2. Now remember, some of you do double T, so go ahead and do your double T to get the same answer. I'm ready to solve each one. Set it equal to 0 and solve. When I set equal to 0 and solve, this will give me 2x is equal to negative 3, or x, once I divide by 2, is negative 3 halves. Leave it as a fraction. Over here, 3x is equal to negative 2, divide by 3, negative 2/3. Awesome. Now, one quick thing. Whenever I'm putting this into Delta Math, you just simply type in 3 halves, comma, negative 2/3, and it will give you your answer. I'm going to go back to my last example. Just a tad bit different. We are almost done, folks. Bear with me one more minute. First thing I have to do is take this 3 to the other side. Oh, but when I do that, it needs to go ahead and match up with negative 2. So this is going to leave me with 8x squared minus 6x. Negative 2 minus 3 more gives me negative 5, all equal to 0. I'm ready to go ahead and do my square box method. Here it is for those of you who need it. That is going to have an 8x squared in the first box, and it's going to have a negative 5 in the last box. I'm ready to go ahead and multiply. That is negative 40. Go ahead and find your factors, which are 1 and 40, 2 times 20, 4 and 10. Ooh, 4 and 10 look really good. I think they could make negative 6 if that 10 were a negative. Would that work? Well, yes, it would. So I'm going to go ahead and put those right on up here. I'm going to put the positive 4x here, the negative 10x down there. I'm going to go ahead and erase that factor so I have a little more space so we can work. And now we're ready to continue. So at this point, I am ready to go ahead and find the GCF of 8x squared and 4x, which is 4x. The GCF of negative 10x and negative 5, which is negative 5. Also going to find the GCF up and down of 8x squared and negative 10x, which is 2x. And 4x and negative 5, which is just a 1. So my two parentheses say 4x minus 5. Second parenthesis says 2x plus 1. I am now ready to take each one, set it equal to 0, and solve. When I solve the first one, I'm going to get x is equal to 5/4. When I solve the second one, I'm going to get negative 1/2. Now, once again, if I'm going to put this into Delta Math, I simply would go. Now, honestly, off the top of my head, I do not remember if order matters. It should not. I would put 5/4. Put a comma, it'll give you another box, and then you write your negative 1/2 in Delta Math. And those are the two places where your quadratic graph will touch the x-axis. Let me know if you need help. Feel free to call me, text me, FaceTime, and we can discuss how to factor and solve.